I'm going to explain my best and amateur perspective on what I call orbital clocks. A clock is that which we use to determine time. The main point of an orbital clock is to determine a measurement of force or energy acting on an object while it is in stable orbit. This includes both the particle and the planet in their normal transits. Since time is measured and energy is measured, the idea springs to mind to calculate energy within a fixed amount of time. Is there a need for orbital clocks? Maybe. It's my interest to roughly sketch in this video the fundamentals of an orbital clock for particles and planets. Some concepts need to be explained. An orbital rotation is expressed as capital P for planet and lowercase p for particle. During normal transit from fixed time with a capital T back to its location at capital T minus 1, we say the object has completed one orbital rotation, listed either as capital P lowercase or lowercase or and lowercase p. It doesn't matter. Allowable resistance is the object's ability to resist force or energy that pulls or pushes or charges it, thereby speeding it up. Allowable pressure is the object's ability to stay intact with external force or energy that pulls or pushes or drains it, thereby slowing it down. A blue line is given to represent the orbital clock's unit of time. This could be in picoseconds or light years. It doesn't matter. The red line represents amount of force or energy applied to object. This line can go either clockwise or counterclockwise. If an event is recorded at t minus x orbital rotations, we go back to t minus 0 as our starting point. The orbital rotation on my diagrams go counterclockwise, but the direction doesn't matter. I also start at 3 o'clock, but that is also up to the user. I place the red line or energy line at a 90-degree angle for illustration as well. The yellow line is extremely important. When designing an orbital clock, the needed information is on the object itself, its mass or charge or state of existence. However, the scientist designs the clock in relation to other clocks, for example, studying the planet Jupiter and its moons, or a bonding process of a group of electrons. The constant quality of the clocks are determined by the yellow line or hypotenuse of the triangle. The foundation of these clocks come from using two specific theorems. The first theorem is known as Thales' theorem, which states that in geometry, if A, B, and C are distinct points on a circle where the line AC is a diameter, then the angle ABC is a right angle. The purpose of this theorem is to show that a clock can be symbolic. The clock notation is not just a meta symbol. Since humans view particles as spheres, and planets for that matter, clocks have been circular in shape. There is no reason why our diagrams can't be more inclusive. It's more efficient to have the information attached to the observed phenomena. In terms of Euclidean geometry, the foundation is there, but many systems require different types of spaces, say hyperbolic, parabolic, Riemannian, Hilbert, and Minkowski spaces. The clocks should reflect that in design. The second theorem is energy equals the speed of light squared times the mass. Taking an abstract approach, a scientist, a philosopher, and an artist have a discussion about the universe. The scientist says the universe is governed by rules. The philosopher states that the rules must not contradict established concepts. The artist asks, why am I blamed if Schrodinger's cat becomes Pandora's box? Let me start the discussion. So in terms of Einstein's equation, it's based off an archaic thought process of our universe. For the purpose of standard science, the orbital clocks are easy to use. His equation is the basis of the yellow, blue, and red sides of the triangle. For more abstract systems, other variations of the clock can be used. Thank you.